Okay, so a few weeks ago we talked about how to find the integral of a function. We also talked about this particular U substitution rule. This U rule, we said that this is a counterpart of the chain rule. So it makes sense that there also exists the counterpart of the product rule. And that's what this integration by part is about. So typically, when you use product rule, you have the two functions being multiplied. Let me call that u times v. Product rule basically says that the derivative of u times v is going to be u times derivative of v plus v times derivative of u. So this is the product rule that we are already familiar with. The integration by part basically take a twist onto this rule by integrate the whole thing. If I integrate the whole thing, then this is what I'm looking at. Now, if I integrate the derivative of uv, what I'm going to get is going to be just u times v. So I'm going to have u times v equal to the integral of u dv plus the integral of v du. Now, if I move things around onto the other side, I'm actually going to, if I move integral of v to the other side, I'm going to get exactly what integration by parts said, which is the integral of u dv is going to be u times v minus the integral of v du. So basically, this is the formula for the integration by part. The integral of u dv is u times v minus the integral of v du. Now, typically, the hard part in applying the integration by part technique is deciding what is your u and what is your v. So, let me actually do the example here. I'd like to find the integral of log of x times x dx. Now, the first thing you should notice, and this is the very foundation to why we would have to resort to integration by part. This is not a simple function, so your usual technique is not going to work. And you try u substitution and that doesn't work. And you actually see that this is product of two things. When you see product of two things, it makes sense that you might try integration by part. That might work. So what you need to do is that you need to identify the integral. You have to identify and the u and the v so that the integral can be rewrite as the integral of u dv. So if you do it right, by the way, you should be able to find the integral of v du. So when you use the integration by part, you will actually change one integral to another. And hopefully, by doing so, you actually reduce the problem. You should encounter something that is easier to compute. So that's the key idea of the integration by part. You see two things being multiplied, you identify them as a u and as a v. And hopefully, when you use the integration by part formula, you get an easier integral to deal with. So let's see. I have here the integral of log of x times x dx. So the first thing that you will have to do is that you have to identify what is u and what is dv. So let's say I'm gonna put this guy, I'm gonna call this log of x a u, and I'm gonna call this x dx a dv. So I have identified my integral that I have to begin with as a u times dv. Now let's see if the u and v that I have in here lead to a meaningful answer. So my u in this here, this is log of x, and then I have my dv, this is x dx. So if u is log of x, what is du? Derivative of log is 1 over x, so du is going to be 1 over x dx. Now I have to also identify v. If dv is x, what has to be v? Derivative of what thing is x? So well, we already knew this integral, so it's going to be x squared over 2. And that makes sense that the derivative of x squared over 2 is x. So if my dv is x dx, then my v is going to be just x squared over 2. So I have identified my v and u. Let's try to plug in the formula now and see if this actually makes sense. So by the formula, the integral is going to be u times v, so that's going to be log of x times x squared over 2 minus the integral of v du. So the integral of v du is going to be my v is x squared over 2 times du, which is going to be 1 over x dx. So that's going to be log of x times x squared over 2 minus the x cancel out. So I get the integral of x over 2 dx. Now I know what is the integral of x over 2 dx. That's going to be just, let me see, x squared over 2. The integral of x over 2 is going to be just x squared over 4 minus a constant. So plus or minus a constant doesn't really matter, so I'm just going to write a plus c. So that is around my final answer here. So that's basically how integration by part works. So notice how we actually have the integral of x over 2, and then we have to find the integral of x to pi sine phi v. So typically that should always happen if you use the right u and v. In other words, if you make the correct choice, typically, when you see an integration by part, sometimes you have to do a little bit of trial and error because you have to kind of, in a way, guess what is u and what is dv. If you have done enough problems, then you might have some gut. The gut will tell you what is u and dv. However, sometimes when you do it at first, you might have to try out to see what is u and what is dv. If you make the right choice, however, v and the integral of v du will be easy to find. So typically, that's the one of the difficult part or one of the key ideas when you try to use the integration by part. Now let's try again with another example. I have now the integral of x times e to the x dx. And then again, so it seems like I have two things being multiplied. So the integration technique that can deal with that is the counterpart of product rule. So this is once again another problem of integration by part. So I'm going to have to identify the u and the v. So I'm going to call this is a u and this is a dv. So let me see. So my u is x. So that means my du is gonna be just dx. And my dv is e to the x dx. Then what is my v? Derivative of v is e to the x. So v is gonna be just e to the x. So far so good. It seems like I'm dealing with something that looks easy enough. So this guy is gonna just equals, let me see, u times v, which is x times e to the x, minus the integral of v du. V du is gonna be e to the x times du, which is dx. Oh, lucky for us, this is all easy, so it's gonna be just this is gonna be just x e to the x minus the integral of e to the x. It's gonna be just e to the x and plus a constant. So that's it. So again, here I made the right choice of u and v, and as you can see, once you make the right choice, once you put in the formula, everything just comes into place. So u times v is x times e to the x. That looks simple. Integrate of v du is going to be just the integral of e to the x dx. So that looks simple. Again, you integrate this guy, you get e to the x. And that gives me the final answer. Now, I said earlier that the choice of u and v matter. So let me try to do this problem again with the wrong choice of v du. So let's see what's going to happen. Let's say I want to find the integral of e to the x times x dx. So this is the same integral, by the way, e to the x times x and x times e to the x. So this is the same integral. But let's say I make a different choice of u and v. Let's say I'm gonna call this guy a u and call this guy a dv. Let's see what's gonna happen here. So my u is e to the x. My dv is gonna, my du is gonna be then e to the x dx. So far so good. My dv is x dx. So that means my v is gonna be x squared over 2. Integral of x is x squared over 2. Now, I'm not running into a problem yet, so maybe this is gonna work. So let's keep going. So my u times v is gonna be e to the x times x squared over 2 minus the integral of v du. So that's gonna be x squared over 2 times e to the x dx. Now then, I run into a problem because I try to find e to the x times x dx, but after using integration by part, I run into x squared times e to the x dx. So that means I'm actually getting a harder question. So that means when you make this choice of u and v, you actually end up getting another question instead of just x. You actually get x squared over 2. So you're getting into a harder integral. So that means your choice of u and v here, when I do it second time, is probably not correct. And yeah.
So this means that this can't be integrated anymore.
Well, you can actually integrate this guy. So actually, this one you can do it by integrate by parts, but it's actually harder than this one. So to actually do this, you actually have to do it again to come back to this form and do the right integration by part to find it out. I will probably have this question somewhere later, so you will get to see. Okay, so I probably didn't have it here. But this one you can integrate it, yes, using by part. But you actually come back to this form and then you have to do the red thing again and blue thing. So in other words, to find this integral, you have to go back using this integral and then this integral.
And will you arrive at the same answer?
Yeah, but you'll do the same, you'll get the same answer. And just so you notice, by the way, there are no general rule on what you should set your u and v be, because in the first example, I let my dv be x dx, and that turns out to be okay. In the other example, if you let your x dx be dv, so this is the same thing, you look closely. If I let my dv by x dx, however, on the second problem, that doesn't work. So sometimes you might have to try out a few times to see what will actually work.